at exam focus BCH 210.1, which is of course general biochemistry. And as a matter of fact, we are going to be focusing on a couple of topics during this session, and these are actually some of the topics that we'll be looking at: amino acid and protein. We have acid and base and buffers as well. Then we have enzymes, we have nucleic acid. All right, so basically we are going to be diving right into it quickly. But if you can hear me and you can see the screen, you can see the video session, please do well to type "I can hear you" in the comment box. Just if you can hear me clearly, do well to type "I can hear you." I can hear you. Okay, I need to be sure that there are people who can actually hear me, that everyone can actually hear me right now. So just say "I can hear you" so we can commence. Okay, all right, so some persons have replied already. Okay, so we are going to be looking at exam focus areas. Okay, in these areas that are listed, we'll also be focusing on other parts, but these are like the core areas we'll be focusing on first. Okay, it's going to be section by section. So we'll be starting with amino acids and proteins. You know that BCH 210 is general biochemistry. Okay, it's general biochemistry, and it focuses on more like the chemical relationship between biological organisms, and of course biological features, biological concepts. That's what we talk about when we talk about biochemistry. Okay, so basically we are going to be commencing with amino acid and protein. Okay, then we'll start with amino acids basically. So basically amino acids are known as building blocks of proteins, right? So we'll commence with amino acids. All right, so amino acids, they are known as building blocks of what? Proteins. Okay, building blocks of proteins. All right, so they are basically the acids that forms proteins. Okay, so when we say building blocks, when we say building blocks, more like collections, boxes. For instance, now if we have these boxes and we heap them on each other, we connect them to each other, and we link them together. We connect them probably with a wood, a very light straight wood. Okay, now if you look at this now, you see that they are all linked, and they are building. The more you add more blocks, they are building up, right? So if someone is building a house, building a structure, the person will most likely put blocks and heap blocks on the other. So the more blocks the person is actually adding, the more the building is actually going up. All right, so that's why we are saying that they are building blocks. They are building blocks of what? Proteins. They are building blocks of proteins. Okay, so the structures of amino acids actually have a common backbone. All right, they have a common backbone. They have a common structure, like a general framework of amino acid structure. We have the structure. The structure is exactly like this. Then we have carbon here. We have hydrogen. We also have the methyl group here. Then we have a carboxylic group. We have oxygen. Then we have OH here. So this is the basic structure of amino acids. Okay, this is the basic structure of amino acids. All right, so if you look at it now, we have a methyl group. We have an amino group. Okay, this H2N is basically NH2. Okay, this is an amino group. Okay, you have COOH, which is a carboxyl, the carboxyl group. Okay, this carboxyl group. Then you also have R, which is also this an alkyl group. Okay, so if you look at this, basically you realize that we have like 3 different groups that are attached that makes up an amino acid. Okay, so everything present here is what comes together to form the amino acid structure. Okay, so quickly we'll be looking at the classification of amino acid. Classification of amino acid. How are my amino acids classified? All right, classification of amino acid. Now we have classification based on the structure, based on polarity, based on metabolic fates, and based on nutritional requirements. And I'm going to be explaining all of these classes of amino acids based on structural amino acids, polar and non-polar. We have the ones based on metabolic fate, then we have the ones based on nutritional requirements. All right, so we'll be going straight first of all into classification based on structure. All right, so when we classify amino acids based on structure, we have different types of amino acids based on structure. Okay, we have different types of amino acids based on structure, and I'm going to be giving you the 9 types of amino acids based on structure. First of all, we have the first type of amino acid based on structure is what we call the aliphatic amino acid. Then the second one is aromatic amino acid. Then the third one is what we call the heterocyclic amino acid. That's the third one. Remember, this is the structural classification. So this is classification based on structure. We have heterocyclic. We have also the hydroxyl containing amino acid. That's OH containing amino acid. All right. Then we also have the sulfur containing amino acid. That is amino acids that have sulfur in them. Then we also have the amide containing amino acid. The amide is actually a functional group. Then we also have the acidic amino acid. Then we also have the basic amino acid. Then lastly, we have the amino amino acid. So look at how many we have: 1, 2, 3, 4, 5, 6, 7, 8, 9. We have the aliphatic, we have the aromatic, we have the heterocyclic, we have the hydroxy containing, we have the sulfur containing, we have the amide containing, we have the acidic containing, we have the basic containing, and we have the amino containing. So these are the types of amino acids based on structure. Okay, based on structure. All right, based on structure. So now I'm going to be giving an overview of each of these types of amino acids based on structure. Now, first of all, for aliphatic amino acids. So basically, these are amino acids that have aliphatic group in their side chain. So these aliphatic. So I'm going to say number 1. Aliphatic. So aliphatic amino acids, these are amino acids that have aliphatic group in their side chain. So they have an aliphatic group. Aliphatic group is actually a type of organic compounds. Okay, aliphatic group in their side chain. So when we talk about aliphatic group and we are relating it to amino acid, I will of course give you an example of aliphatic amino acids. All right, I'm going to also draw the structure. Now, examples of aliphatic amino acids that have aliphatic group, we have glycine, we have the alanine, we have valine, we have leucine, and we have isoleucine. So these are examples of amino acids that have the aliphatic group. So I'm going to be drawing the structure of glycine, okay, which is the first one. I'm going to be drawing the structure of glycine, so you would have an idea of what we mean by having an aliphatic group attached to the side chain, to the side chain. Okay, so basically look at the glycine structure. Remember, don't forget that this is the general structure of amino acids. All right, then for glycine, Okay, the glycine structure is exactly like this. I'm going to be drawing it. So we have, don't forget that you always have your amino group by the side. Then you have, of course, here carbon here. Then you have a hydrogen here. All right, you have another hydrogen here. Then you have your carboxylic group. Okay, now it does not have any functional group. It does not have any functional group in the side chain. It has an aliphatic group. Now when we say aliphatic group, if you look at the structure of alanine, okay, if the structure of alanine is like this. Alanine is like this. We still have H2N here. I'm going to be making comparisons now so you understand what I mean. We have H2N here, we have CH. Then down here we have a methyl, that is CH3. Then we have COOH. This is alanine. This is alanine, which is also an example of an aliphatic amino acid. So now basically there is no additional functional group aside the amino and the carboxylic here. There's no additional. We have some structures that have like a benzene that is attached. That is an aromatic group. But in this case now we have just an alkyl group. That's what makes it aliphatic. We have just an alkyl group, CH3. All right. Then of course we have just H. So when we have H, when we have hydrogen, we have CH3. We have something like we have CH2, CH3, which is ethyl. These are alkyl groups. All right. These are alkyl groups. So basically, for valine also have an alkyl group. In fact, valine has an alkyl group that contains 3 carbons. All right, that contains 3 carbons. Let me draw the structure of valine here. Let me draw the structure of valine here. Remember, valine is also an example of an aliphatic amino acid. All right, so valine still have, of course, because it's an amino acid, you have your H2N here, you have your CH here, you have your carboxylic acid here. Then down here now we have another carbon that has 2 carbons. We have CH3, then we have another methyl here attached. Then of course here will remain only 1 hydrogen because we have 3 bonds, so we have only 1 hydrogen here. So now you see this part here. This part here now is the alkyl group. This is the alkyl group that is attached to this particular chain. That's why it's called a side chain. All right. So this is valine, which is also an example of an aliphatic amino acid. All right, aliphatic amino acid. Leucine also have an alkyl group. Isoleucine have an alkyl group. So basically, all groups that have all amino acids rather that have alkyl groups, okay, are aliphatic amino acids. All right, aliphatic amino acid. So isoleucine is still something like this. We have H2N. We have H2N, which is the amino. We have carbon, a central carbon, which is the alpha carbon. We have COOH. Then here now, down here, we have another carbon that has, like, we have CH2, CH3, an alkyl group that has 4 carbons. Then here now we have CH3. Then now to complete here, we have what? Our CH. Now this, at this point here, this is where we have the alkyl group at this point. All right, this is where we have the alkyl group. Okay, so you have to actually, if the best way to actually remember these structures is when you actually know the what is connected to the side chain, the functional group that is connected to the side chain. Okay, so this is what the structure of isoleucine. This structure of isoleucine. All right, so that's for aliphatic group. Remember, I gave you about 9 of them. I said we have the aliphatic amino acids, we have the aromatic amino acids, we have heterocyclic, we have hydroxy containing sulfur, amide, acidic, basic, and the amino acid. All right, and the amino acid. So basically, we are going to be looking at the next one, which is the aromatic. All right, the next one, which is the aromatic. But I want to be sure, can you hear me? Can you hear me? Are we together? Can you still hear me? If you can hear me, say I can still hear you, sir. Say I can still hear you. If you can hear me, say I can still hear you. Thank you so much. Good, that's perfect. All right, so now let's proceed. So when we talk about aromatic amino acids, so aromatic amino acids are those amino acids that have a benzene ring in their side chain. Remember, I said that aliphatic has an aliphatic group. So this one has like a benzene ring, a benzene what ring? You know how benzene rings look like now? Benzene looks like this. Benzene looks like this with a ring at the center. With a ring at the center or something like this. The one that has what double bonds. 1, 2, 3. That's also benzene. So when a benzene ring is actually connected to an amino acid, okay, it's called an aromatic amino acid. All right. So common examples of aromatic amino acids are called phenylalanine and tyrosine. All right. So we have phenylalanine. Anytime you hear phenyl, anytime you hear the word phenyl, it has to do with benzene. Phenyl is even the substituent benzene. When benzene is a substituent, it's called when benzene is a substituent, it's called phenyl. All right, it's called phenyl. Phenylalanine and tyrosine. All right. So these are examples of aromatic amino acid. So like phenylalanine, what makes it aromatic? Now look at the structure of phenylalanine here. Of course, you know we always have our H2N, then we have CH here, then we have COOH. Then the side chain, usually if you notice, it's all the time is connected to this alpha carbon, this central carbon. Then here now we have CH2 and bonded to what? Bonded to a benzene ring. Bonded to a benzene ring. Okay, bonded to a benzene ring. So this is phenyl what? This phenylalanine. This phenylalanine. All right, phenylalanine. This is structure. So this is a benzene ring attached. That's why we said that it is an aromatic, rather it's an aromatic what? It's an aromatic amino acid. Then for tyrosine, the structure of tyrosine is like this. Remember, we always have our H2N bonded to our CH, then what? COOH. Then this central carbon, which is the alpha carbon. In this case now, we have what? CH. We still have CH2. We still have CH2 here that is bonded to what? That is bonded to our what? Our what? Benzene. Okay, but now instead of it just bonded to benzene, this is the bond though. Instead of it to be just bonded to benzene, here as well we now have an alcohol. So it's bonded. So now this guy as a whole like this now is called phenol. It's called phenol. When an OH is added to a benzene, it's called a phenol or benzene alcohol. So it's almost like this. So but now at this point now for tyrosine, at this point now we have OH. At this point here, we have OH. Are you seeing that they are similar? The thing that is common between both of them is that both of them have a benzene ring that is attached.